Factoring special cases. The first one is perfect squares. Now, we are still dealing with trinomials, but this is a shortcut. This is a special kind of trinomial that will let you skip the area model and go straight to this. Now, for these problems, you can still do area models if you want. Take out the GCF, use the area model, you'll be fine. But if you recognize a shortcut, oh, it's so much faster. Let me explain. When you see the first and the last term are perfect squares, and now what I mean by perfect squares are numbers like these. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Like these are the most common ones. Now you can go further, like there's some more. 121, 144, 169, but honestly, I stopped memorizing perfect squares after this, so I need a calculator to do these. Okay, maybe this one's 225, but I don't memorize all of them. I just recognize the first 10 usually are good ones. Now, if you recognize that the first and the last term are perfect squares, now there is a number here. Remember, this number is 1. If you recognize they're perfect squares, you know your answer will look like this. Well, what does this mean? If you take the square root of those numbers, that's what's going to be in your parentheses. Okay, let me explain. So if I take the square root of this and this, I get 1x squared. The square root is, let me take the square root. The square root of 1x squared and the square root of 36. I get 1x and I get 6. Now, if these were combined, what is 1x times 6? 1x times 6, if you put them together, gives you what? 6x. Now, what should be in the middle for this to work? Double that amount, twice that amount. What is it if you double a and b? If you double 6x, 12x. So if this works, if this matches the number you have here, then your answer is just going to be this. And you're done. If you did the area model, your answer would be this. This would be what you get in the area model. But because they're the same, you could just write your answer as x plus 6 squared. Okay, now this is a shortcut. Again, here, if there's a minus sign, it's not a problem. Only the last one needs to be positive. And if you notice, that is positive. Okay, so you take the square roots. Square root of this, square root of this. That is 2x. This is 10. If I put these two together, I get 20x. And that is double. So my answer is just going to be 2x minus 10 squared. That's it. That's it. I don't have to do anything else. Okay, so this is just a shortcut you can use. I highly encourage you to try to use it. Now, it could get a little bit more complicated than that. Let me show you one more. Let me show you what happens if you can take out, if it doesn't look like it'll work. Well, this doesn't look like it'll work because that doesn't have a square root and that doesn't. But if you notice, the x's aren't the same because when you're doing these problems, remember, when you're doing these problems, they should look like ax squared plus bx plus c. But there shouldn't be an x there, or an x squared there, or an x cubed here. So that means we can take out a GCF probably. And if this is the smallest number there is, it's probably going to be 2x. Okay, so if we take out 2x, that's your GCF. What would be left inside would be x squared here. The 2's cancel out. Minus 18. 1x cancels out. And plus 81. The x's cancel out. So you get this. And now you can focus on just the inside. Again, remember, this is a 1. And 1's have a square root. This is 81. This also has a square root. So if you take the square root of these two, I get the numbers 1x and 9. If you put those together, you get 9x. And what do you notice? That's double. 9x doubled is that. So this will work. Your answer for this should be x minus 9 squared. That's the answer. Now, how do you know it's a minus? I use the sign in the middle. Because it's a minus sign, I put a minus sign. If it was a plus sign like this one, I would put a plus sign. Okay? Now, this is an optional shortcut. I think it'll save you a lot of time, but if you prefer Xbox and area model, go for it. But this will save you so much time if you do it correctly. Okay? So, perfect squares,